This next method of separation is called simple distillation, and this is when you want to separate a solvent from a solution. So simple distillation can be used, for example, to collect pure water from seawater. So what we just did in the last experiment was we evaporated off all of the water and kept the solute. However, what about if you want to keep the solvent? So what happens if you want to keep the water? Well, this is the setup that you would use. Also, this can be used to collect copper sulfate crystals from copper sulfate solution. So in the pear-shaped flask here, I have copper sulfate solution. So our setup is that we have a round bottom flask. Above that then we have a still head, okay, and a connecting piece of apparatus that then moves on to our condenser. And you'll notice that there are two black pipes coming from here, and this is to allow water to come in and come out. Water comes in from the tap to the bottom of the condenser and moves around the outside of the glass tube and then comes out the top of the condenser. And the role of this is just to keep the condenser cold. You'll notice then that there is also a thermometer right above the flask, and that will tell us then the temperature at which water evaporates, which is at 100 degrees Celsius. At that point, the water in the solution will then rise, and it will tell us here that it's at 100 degrees. It will pass down the condenser, cool, and then cool back and condense into liquid water. So condensation is the change of state from a gas to a liquid when it is cooled. I should add as well that there is a chemical added in here called anti-bumping granules, and they are added to the mixture in the flask to promote smooth boiling. So just in summary, the vaporized solvent passes into the condenser where it cools, condenses, and then runs into the collection vessel, which is our beaker. The distillate is the liquid that is cooled from the vapor and collected during distillation. So the liquid that we collect over here in the beaker is called our distillate. So what we are now beginning to see in the pear-shaped flask is that there are bubbles beginning to form, and this is indicating to us that the water is going to boil very soon. Another way that we can tell this is by looking at the thermometer, and it is just above 30 degrees, but we will notice a really sharp jump in temperature as it reaches its boiling point of 100 degrees. So we can see now that there is rapid boiling of the reaction mixture, and we're reaching about 90 degrees Celsius. The anti-bumping granules promote the smooth boiling, so it stops the liquid in the flask from shooting up into the condenser. So as the vaporized solvent then moves up and passes down the condenser, due to this being extremely cold, the hot gas then condenses back into the liquid form. And if you have a look over here, you can start to see the water then, pure water, condensing into the beaker. So now what we are left with in the pear-shaped flask is the pure solid copper sulfate crystals, which are that nice blue colour. And over here then in our collection vessel, we have our distillate, and our distillate is pure water. So this method of separation is used to separate a solvent from a solution, that being water from copper sulfate solution, leaving the copper sulfate crystals or the salt in the pear-shaped flask, and then in the beaker we have our distillate.